So many of us have an idea that an artificial intelligence system are regularly making benign decisions like recommendations from Amazon or from Netflix. So what about systems that can have significant impact on a human's life? Should AI systems be really used in cases like sentencing criminals? So since we know that all human decisions are with bias, we are here to present this project in the hopes that it can augment not the decision, but how cases are prioritized with the growing backlog of cases in all criminal courts, not just in Nepal.
Thank you, Cindy. So our idea here is legal case hearing prioritization. So the number of cases that are being recorded every day is increasing daily, but the number of people who can manipulate those cases are still the same. So what we propose is a system that can take a look at those cases, that can analyze those case files and suggest a priority for that can assign a priority for those documents. So our idea also aligns with one of the 16 Sustainable Development Goals proposed by United Nations. So here are some data. The first thing is there are about 255,000 cases that are being registered daily, and about 88,000 cases are backlog cases, and there's about 61.8% disposal rate. That means the cases are in some way they are not getting solved because maybe the documents are unavailable, or maybe the person who needs to come is unhealthy. So there are a lot of the cases are categorized into a lot of different things, but the category of the cases can be prioritized. So some of the cases like corruption, the violation of constitution, or maybe death threat cases can needs to be solved urgently, and some other cases can has some time to be solved. So we propose a decision support system for prioritizing case hearing in Supreme Court, and we use natural language processing, machine learning, and deep learning algorithms to do this. So the data available to us is publicly available in the Supreme Court website. So there's the documents, there's category of those documents, and the priority scale of those documents. So we use that to train our model. So the key benefit that we get is the people who are taking a look at these documents, they have some time to do some other stuff, and also it decreases the delay. So an overview of what we do is we compare two methods. We compare our traditional machine learning methods and we compare it with deep learning methods. And to do this, we take a look at the previous case files. So the first thing that we do is topic modeling and unsupervised learning. So what we do in this method is the topic modeling is unsupervised learning algorithm. So we use unsupervised learning algorithm to get a metadata information for the supervised learning algorithm. So we give our model a set of documents for topic modeling, and what it does, it gives us the distribution of the set of words in the documents. Before this, we need some pre-processing like vectorization, tokenization, and we can have some of the words which can be left out. And we get a distribution of those topics. We get the frequency of words in each of the document, and we can use that as a metadata for our supervised learning algorithm. So in supervised learning algorithm, we use a multi-class classification in which we prioritize case as if it needs to be solved urgently, or maybe there's some time solving it. So then next thing we do is we have some other algorithms so that we can compare it. So I'd like to hand over the mic to Moise.
Thank you, Abhishek. So Abhishek talked about baseline algorithm. So we might as well take a few other algorithms and then try and compare which works okay, which works better. So one of the other ways would be use by LSTM. And this has been shown to be useful for document text classification from some recent works being done. So what you could do is, since that it's been already said in this workshop that AI, most of the algorithms are modular. So what we can do here is not just use by LSTM. You apply word embedding first, and then project that into a latent vector space so that things are more low dimensional, more continuous, and then give that to a by LSTM model. And then so different ways you could get an output is either do a binary prioritization, which means we already have example whether this case was prioritized over other or not. We already have that history, so which means you don't need annotation. So for that, you might use binary cross entropy at the end, or if somebody of some of the clerks could give you some kind of prioritization, 4 levels of prioritization, then similarly you could add another multi-class classification layer after the fully connected layer. So that's one of the ways you could do it. Also, not just the text, we could use metadata. Who was the entities there? Pakshi Vipaksha ko थियो भन्ने कुरा. Next slide. So this is what the high-level overview looks like. You have an input, you do an embedding. So we're using 1,000 of the first 1,000 tokens, assuming that those 1,000 words itself can represent what the whole document talks about. So you apply embedding, you use 100 dimensions, put it into a low-dimensional space, and then merge the results of the LSTM, and then give it to a fully connected layer, and then whatever kind of priority classes
you got 1
want.
minute. You got 1 minute.
Sure. Thanks. So again, not just that, you want to do some sort of pre-processing. Maybe do a tokenization, remove stop words. We're talking about Nepali language, so maybe you'd want to develop a model for that. What do you do with out-of-vocabulary words? And then since we're using word embedding model by LSTM, it turns out that the different varieties of word embedding you use doesn't matter for the overall results. That's what the literature says. That's it. So these are all the references for some of the works that has been done. So thank you.
Okay. Can I ask Team 2 to come here and set it up? And in the meantime, we'll ask questions to Team 1. So Team 1, this side, please. And Team 2 over there. Okay, we have 2 minutes for questions.
Have you ever been in dilemma whether to trim your beard or not? If so, then we have a solution for you this problem. Good afternoon, everyone. It's me, Ravina Karki, representing Team 2. And in my team, most of us are students. Before going to the idea representation, I'd like to thank NAAMII team for this great, amazing opportunity. Thank you. And these days, people are really passionate about having different type of haircuts, and having different type of beard style is more trending among boys. So imagine yourself going to a barber and he shows you different type of style of hair and as well as beard. And you get really confused whether to choose this style or that style. I once went to a hairdresser in order to cut my hair. But after when the year cut was completed, I was really disappointed with the look that I was looking. So in order to solve this type of problem, we are here with a solution. And the solution is that if I had knew that I look that disgusting in that haircut, then I will never go for that haircut. So we have a solution for this, and the solution is that before having my haircut, I will imagine myself, or I'll visualize myself in that haircut, and then I'll go for that cut. So the inspiration and overview of this project is that you can visualize how you look in that hair or beard style. Further more information, I'd like to call my mate Bipin for more. Thank you.
Thank you. Hello. Thank you, Ravina. So yesterday when Vinod sir was presenting his presentation, uh, he was basically presenting very interesting. His research was really interesting. Man, wow! If we can, if we can generate that sort of images by changing different facial expressions and lighting, imagine what we can do. And we were thinking on that, and this idea struck to us. So we thought that maybe we can add something to Vinod sir's project. Maybe just instead of just changing person's expression from smiling to frowning, maybe we can add beard to that, add hairstyle to that, add clothes style to that. So on thinking that, and when we were thinking on it, and Chris pointed out to us that we can do this add this in Vinod sir's project in this way. Like we can from person's 2D picture, we can use reconstruction GAN to generate a 3D model like in Vinod sir's project, and we can do image-to-image translation like style transfer way or a generated GAN way to add a beard to that image. So in a 3D model, we can add beard to that. So we can train that with beard dataset, like by using person with beard and without beard. Maybe we can encode this information in the latent space. Like next slide, please. Next. Maybe in Sir's project, he pointed out that we are training with different facial expressions and lighting, and all those information are actually encoded in the latent space. So by tweaking that alpha parameter, actually we can change we can generate the that beard or lighting conditions. We can like interpolates in between that. So maybe we can train the same model by providing a lot of data sets, and maybe GAN can encode these informations into new PCA vector. So we can now, by doing this, we have actually added an alpha beard parameter. So by changing alpha beard parameter, maybe we can generate beard to that person. And maybe in this PCA axis, if we change alpha, maybe we can change the intensity of that beard. And if we go a little bit far, not in the same mean axis, maybe if we go a little tweak sideways, maybe we can generate different type of beard. So maybe this method, it can, so we are doing a lot of maybes. So in this method, maybe we can, by providing different kinds of beard in our data sets, we can not just create the same style of beard, but different kind of beards. By just going a little bit sideways from the actual PCA axis. So this is our idea. So next slide, please. Now this is one data set which we found with beard and without beard. Next. So what can be the possible benefits of these ideas? Apart from what Ravina pointed out, it can be extended to, it's not just limited to beards and hairstyle. Imagine a situation when a movie maker or filmmaker is imagining about a character, possible character, and he's thinking, how should he look? How should he look in this film, in this movie? So for that case also, this can be useful. And not just that, I think this can actually help a lot in the fashion industry. Like if we can actually visualize ourselves before actually doing that dressing a thing, it can help. And not just that, in previous presentation, our friends pointed out that it's helpful in legal cases. So it can also, I think, I can think of a situation in which this can be used for the legal situation. So imagine a criminal, police has a database of criminal without a beard, and he grew beard and committed a crime. So we can actually remove a beard by changing alpha parameter, and we can match that with a criminal database. So this can be used in a lot of scenarios. So those are the things we actually thought, and like fun for us to think this. So I'd like to thank for this brainstorming challenge, I guess. Thank you.
Okay.
So, check. Can I have a show of hands? Like, how many of you live in Kathmandu Valley? Right? So, can you read this? That's quite near. That is correct. So, but The thing is, I don't understand it. I'm a newer, but I don't understand it. And it's a script called Ranjana. And our problem is we're trying to solve this issue. And the name of our project is Newa Reader, and I'm Nishan. So the thing is, this script is used in a lot of places, from temples to old books, and most of us can't read it. And the thing is, this used to be widely popular and everything, but since Prithviraj Shah conquered the whole Nepal and everything, this slowly stopped being used, and right now we don't really understand it. So the question is, why create it? So this is probably the first Newari Osia, and we want to be able to document old historical documents using this technology. And furthermore, we will also like to promote our old indigenous languages and languages. So we want to create a Newa text recognition system. And the reason we really want to do it is because this language is very culturally important, and it is present in all of our temples. And we would like to digitize this historical scripts. And at the moment, there are communities that are involved in teaching this language, and we'd like to somehow collaborate with them to further our project. And I'd like to ask Ramesh to further expand on this topic.
So the problem to our solution is we don't have a data set. The Newari data set is not been created, so we will be the first one to create it. The Nepal Bhasha, it is called Nepal Lipi or Nepal Bhasha, will take 25 native writers, and there will be 36 character classes, same as our Nepali language. And then there will be 1800 samples, because every native writer will generate 2 characters. So the data set will be created. So our methodology is we take natural scene images we see around ourselves, like we go to the temples. There are many temples around Kathmandu where the monuments and manuscripts are written in Newari language. So we take the natural scene images, and then we go through the detector. The detector detects the Nepal Lipi or Nepal Bhasha, the script. The top one here is the waiting card, so it will predict the bounding box, and then the recognizer will translate it to the digital Newari language. So the proposed system is, there is an image, the same natural scene images, and then there is a localization network. The localization network locates the text, the Nepal Bhasha Lipi, Newari Bhasha Lipi, and then the localization network generates a grid. The grid is around uniformly distributed around the Newari Lipi, and then the bounding boxes are generated through the grid generator. So there is a soft sampling. The sampling will take the grid pixels, and then will feed it to the recognition network. The recognition network is a ResNet, so it is a layer of convolution networks, and then the output is generated because there are 36 classes we have to predict. So this is a more robust network we are planning to build. So it might be able to detect even the documents we have in Nepali Lipi. So Nepal Bhasha Lipi documents are all over Kathmandu. So we'll be able to generate the digitized text. So it's the same. It's the first one here is image feature extractor. So it's nothing but convolution layers. So there is dimensional reduction through reshaping and connecting it to the dense network, fully connected network. And then we'll use for sequential modeling, we use GRU gated recurrent network through the loss will be calculated through CTC. Connection is temporal classification. What we really need is sequential modeling because the text need to be classified according to the probability basis, because if one classes of the text can be generated through the probability classes, we might be able to predict more number of texts. So, thank you.
Hello everyone. So our project is it's a assistive tool for children to learn handwriting. But before I get into our project, I'd like to motivate the reason behind this idea. So how many of you here have watched the movie Tare Zameen Par? How many of you have cried watching that movie? Yeah. So for those of you who haven't, it is a story of Ishan, a dyslexic child, just trying to get through his life and navigating his school, and a teacher comes into his life, and then he tries and rebounds from it. And so our tool is something that is aimed at children to help them learn handwriting, which is something that people with ADHD or autism or dyslexia find really hard, and they struggle to get through learning handwriting just like normal people do. So what we propose is a personalized learning tool which can help any student to learn handwriting and for any particular language that of their choice. So this is aimed at children who are between 2 to 6, but we are pitching this as a product for children in general, because you can't just look at a child and say who has autism and who doesn't. So what we are aiming for is an AI which is going to replicate what Amir Khan did in the movie as the teacher who's going to assist the child. So here's an example of what it would look like. It starts with teaching them shapes, basic shapes or basic alphabets and numbers, and we'd like to progress to Nepali alphabets, if you are choosing Nepali, for example. And so how do we tackle this problem? This is the kind of existing device applications that are there for students to or kids to learn letter writing or handwriting. And what we have, which is not there, is ours is more like a unsupervised kind of a method. What they offer is just joining dots in order to get their letters right, but ours is more of a write from scratch without any kind of a dot kind of an approach. And so that is kind of a depiction of the kind of AI that we are going to replicate. The teacher there helping a student who is struggling with handwriting. Right, so if you look at the two alphabets here, this is the alphabet Ka in Nepali, and it is wrong in a few of the parts there. So, I mean, these could be inputs that could give you an idea about how much they struggle in writing and which part they are getting it wrong. So it can be trained. I mean, dyslexia or ADHD is something that can be cured with training. And all you need is an AI that can assist and tell you where you're going wrong and which part exactly to focus on. So our idea is to have the kid write a particular alphabet and point out the parts where they go wrong so that they can extend on or get the shape right. And in that way, maybe train them in order to get their handwriting skills to a good level. Why does it not go down? I'm sorry. So, yeah. So another benefit that we offer is like when we are trying to isolate which part of the character exactly goes wrong. So this is something that other existing devices do not offer. So if, let's say, these are the 4 chunks that you can split the character into, and so we can narrow down into exactly which part of the character is not right. And so how can we solve this kind of a problem? So from whatever we have learned in class, it can be thought of as a problem in key point detection, let's say, we've learned methods like SIFT, which we've used to tackle the kind of problem where we just try and find, let's say I have a supervision for the say car. I can compare a point here to the original image, and I could say that maybe it is that part which is not in line. But if you try applying that to this kind of a problem, you would see that your results are not as good. So we have tried using an attention-based model, using a neural network to tackle the problem. So what we are planning to do is we are having a model that compares every patch of the image of a character, patch by patch. It is very similar to how humans would find like the odd one out or something. So let's say I have two images and I ask you to spot the difference, what would you do? You wouldn't go look at the whole image first, the first image, and then go to the second image. What you would do is you would look at one part of the first image, then you would go to the second image, then you'd go for another part of the image, and that is how you would spot a difference. So this is something that is mapping the exact same kind of intuition. The data set that we've used to train the model here is the Omniglot data set, which is a collection of random letters from different languages. DHCD is a data set that is available for Nepali alphabet, and which is what we are trying to use when we are going to deploy it for maybe Nepali language. And the kind of features that we extract are convolutional features, and which is based on only raw pixel data. So there is no other supervision for our model. To explain the model in more detail, so you could think of this as a recurrent neural network. So if some of you might have heard of attentive recurrent comparators, so that is the model that I'm talking about. So it's a recurrent neural network, the kind of network you have studied, which is used for language. So you might have known of LSTMs or RNNs as a kind of model that you use for language, but here is an idea of using it to train an image patch by patch. So all it does is, it is going to learn some hidden state, which is H. Okay, I can point H, and from which you extract an omega, which is going to point to some XY coordinate and how much of a zoom is needed. And with this omega, you are going to look into the image and look at a particular patch. With this patch, whatever you get is the glimpse, which is again fed back into the RNN, and you repeat that for the second image. So what you will do is you'll go to the first image, have a look, take a glimpse, come back to the second image, take a glimpse, go back, you repeat it, as long as you find a similarity. So here's an example of the attention model. So you can see that the number of glimpses, it goes from 1 to 16. 1 to 16, and you'll see how the size of the attention mask keeps reducing. So it learns to compare how similar the image is and where exactly it can localize the places where it is not exactly right. So that's about it. Thank you.
More about the motivation for this project, and also if you are envisioning, I don't know, replacing teachers. Like, what is the role of instructor, teachers? There could also be teachers for special ability kids, the symptoms you were talking about. So would it be a tool that will aid them, help them, or would this be a tool on its own where you would not need anyone else to supervise?
So right now, when I've pitched it, it is envisioned as something which does not need a teacher. The AI is the teacher. But yeah, considering that this problem is a little difficult, maybe in the next versions, maybe we would have a functionality where a teacher could come in, or it's similar to what Grammarly does. So Grammarly currently has a neural network module which looks at the grammar, but it is possible to have like a premium version of the app where a teacher can come in and give extra feedback and things like that. So this can be used by any student. It's not, I mean, you can't say that this kid already has ADHD and then you give it to them, right? So this can be used by any kid, and maybe if you find that maybe this kid has some defects, and then you could maybe try and have a dedicated teacher for that kid. So that could be one option of having a teacher come in and give their input.
Okay, one more question.
So, considering that teaching a dyslexic child is a really difficult thing,
Yeah.
what do you think how difficult it will be for AI to teach him?
Difficult it would be.
Like lot. Okay. So to be honest, like we do not have enough information like to claim like it will be very it will work for children with autism, but with enough data, with enough like whatever we can come up with we may come up with, like I cannot say for sure, but we can take this approach and maybe come up with a solution or like to help those child.
I'd like to add to that. So among the other methods that are prevalent, I don't think there's anything else which can do at least to this level. So everything else is like join the dots to make the character. So maybe this does not solve the problem, but I think this is the best that is there right now.
One way to answer his question would be, AI will not completely solve this problem. You will take this product and consult with teachers who have experience working with dyslexic kids, and then try to find a pedagogical method to teach them writing or something.
Okay.
Okay, we need to stop. Oh, sorry, Chris, yeah, please.
Okay, it's a kind of related question, is that I wonder kind of if this kind of app just appears on the internet, right?
Okay.
I expect that the people who will start using it immediately are the very kind of disciplining parents who are like, you are going to perfect your handwriting,
okay.
and then the people who really maybe need it the most are the ones who might be least likely to actually use it, right? So I don't know if you have any idea of like how would you address something like that?
Make it accessible to everyone. I think making it an Android app is as much as we can go. I mean, so that everybody can access it on their phone, which is like a free app. But for people who do not have internet or things like, or a mobile phone, then we'll have to come up with something else. Do you have anything to add?
I think we don't know the niche of this our application without like without publishing it into like deploying it into App Store or Play Store. So after that, like we can collect the information about the users and like according to their maybe I don't know like different things like demographics or things like that, and then we maybe like come up with like a model that will address those target groups, I think. Did that answer?
Thank you. Thank you. We need to stop. Round of applause.
So, a very good afternoon to all the mentors and my dear friends. I, myself, Minu Saraf, and my friend Gaurav Panwar are going to represent our idea on the behalf of our team, which is AI-assisted monitoring for drowning detection. So, before moving forward, I would like to ask how many of our parents feels unsafe when we ask them, can we go for swimming, especially in the rivers and the lakes? So I think that is a major concern of all of our parents. And this concern is not fake. I mean, that is genuine. According to the World Health Organization, every year, around 372,000 people dies because of drowning. And this is a huge. And Nepal is, of course, not an exception. As Nepal is a God-gifted country, we have a lot of natural resources, rivers, and beautiful lakes. But there is a huge risk of dangers as well. And keeping these problems in mind, we have come up with a solution which is a computer vision-based monitoring system for drowning detection. Here, what we basically do is we are going to keep cameras on the rivers and the lakes, especially on those areas where the probability of having the danger is very high. And on the basis of those cameras, our lifeguard will be able to access all the cameras on a single screen, and if there are any of our person will be missing according to our algorithm more than 10 seconds, then our lifeguard will get an alert and he will be able to think what will be the next step. And in order to further describe, I would like to call Gaurav.
Thank you, Meenu. So, okay, so I'll be taking the technical part here. Before starting with the technical description of how we finally ended up with a final solution, how we would implement this, I would like to say the main theme about this implementation is what we want to convey is there are many problems we have solutions, ready solutions that we can just implement and solve them. And we found such many problems, like in discussing we had many ideas, so this is one of that idea. The main aim is that the solution is pretty straightforward, and like Chris had mentioned, to solve problems we have to start collecting data and implement the solutions. So our aim is that we want to collect data and solve the local problems, which will help AI being more inclusive. Yeah, so the way it works is we have cameras which track people in the, like I'm going to take an example just to be more explanatory. In a river, a camera is supposed to track people, and yeah. So if the algorithm fails to track any individual for more than 10 seconds straight, it will alert the lifeguard, which has stream of all the cameras into a single screen, and it will also give an estimation of location of the last last scene point, so that lifeguard can use that information and take the further due action. Yeah, so this problem we have broken down into simpler problems. One is the ML one, which is object tracking, multiple object tracking, and the second is more of rule based, where we decided we came up with some corner cases that we have to handle, and we also had the solution of how would we handle them. So there are two things. One is multi-object tracking, and second is more of an application side where we'll have the frame rate counter and basic programming, which is very basic and doable. Yeah, so for training we'll need we will have we went through different algorithms. So our tutor had gave us a reference of literature survey on multi-object tracking, the classical ones and the new ones. It explained us what are the challenges in multi-object tracking and how the state of what is actually really getting the accuracy very high. So we'll be using deep neural network for object detection and tracking. The images will be collected from the river on the normal days, and the labels will be the people in those rivers. Yeah, so as I said, the core engine is multi-object tracking. So there are two types. One is detection-free tracking and detection-based tracking. Detection-free tracking is more of like a classical algorithm where object detection had nothing to do with the tracking. You can use any Euler-Jones or Hawk-based detector, and things. Kalman filter could be used for tracking, which is like an initialization is done by object detection and filtering. So there are many drawbacks, like we cannot, there is no probabilistic model saying is the tracker gone off or is it detecting the wrong object. But in object detection based tracking, yeah. So in detection based tracking, okay, the image is not there. Yeah. So in detection-based tracking, object detection and tracker work together. The features are shared, and the combination really works. We are looking at the paper called which uses YOLO, the very famous object detector, and we use LSTM. So it is called as ROLO, recurrent YOLO, done by a PhD guy from University of Missouri. So we have a demo here showcasing what exactly will object tracking do. It's not work. Okay, yeah, maybe we can look at it later. Yeah, so So our main point is if we collect data and we already have such object tracking techniques which can be applied to many applications like that, we just need to focus on them and implement them. That's it.
Thank you. Can I ask the next team to come over? And
I think you are planning to deploy this system.
Rivers, lakes, where there are crowded areas and it is difficult to manually monitor if there is any person drowning or is suffering, things like that. So cameras have a really good quality if you keep it high resolution cameras, and that too like IR cameras which can work in dim light or night vision. They are better with the crowded kind of scenarios than the manual lifeguard looking for such kind of potential dangers.
I think besides river and lakes, you should also consider using on the streets of Kathmandu during monsoon.
Mike, I have a question.
Yeah.
So, if I want to go swim in Bagmati River, the water is pretty opaque because it's black. I don't think the camera can see through the surface. So can you use sonar cameras and use the same system?
So
if you don't have visibility on the
So
water?
IR cameras can work in this thing
IR
at
camera,
night.
okay.
Yeah.
Oh, you're using IR cameras.
Yeah, surveillance kind of a setup where it should work at night and at daytime.
Yeah.
So I guess like when you said it might be difficult to track, the difficulties are more of like occlusion and like variance in appearance of an object. So deep learning networks are actually really good and the performance has been really promising. So basically our point is everyone is trying tracking on a car, which is obviously in US or some other country. But they are like the only thing is data which is stopping us. The algorithm is there, the tools are there, understanding is there. We don't have the data just to train and test it out also. So we think it is not really a good thing if we don't have data at least to disprove this theory. There is no one claiming that this cannot be done.
Everybody has skin diseases, right? All of us go through skin diseases at one point in our life. So what we are trying to do is create an app that will take the images from your phone and predict what disease it is and provide prescription based on that disease, or tell you to go to the hospital if you need to. So I'll continue on with my slide. Okay, so the overall idea is to analyze the images captured from smartphones to detect the skin diseases and maybe even provide prescriptions. So this is nothing new. So what we are trying to do is add on like multiple disease detection, like something that would allow us to give prescriptions after detecting those diseases as well. So that is the evolution that we appended on it. Okay. So the key benefits will be self-diagnosis, right? So skin diseases are embarrassing. All of us know that and all of us go through that. So what we are giving you is an alternative to do it yourself. You don't have to like go to the doctor or face any embarrassment or something like that. So this is also a method to simplify skincare. So what it is you have to go to the doctor and they will check you and they will give you, various tests and stuff like that, and they will provide you like a final diagnosis, right? So with this, what you will have is like a mobile unit which will tell you what kind of disease you have, or if it's a simple one, it will just classify it and give you a prescription. If it's a complex one, it will tell you that you need to go to the hospital. So time efficient. So it will be time efficient, both for you and the hospital. So moving on. So the high-level methodology we are trying to implement here is like get the infection images, find the contour and feature images, generate predictions based on those features, display the findings, calculate dosage and routine, and then provide suggestions. So the basic premise is you will take the photo of the infected area, and the infected, you will put that in the device, and the device will calculate predictions based on that photo. and give you an idea of what you might have, and then based on that, give you prescriptions if you need to, or tell you to go to the hospital. And then what it will do is also provide you the dosage and the routine of how you will take the medicines. So skin disease facts, these are just basic information I wanted to provide. So commonality, skin diseases are really common. So a lot of cases that a lot of cases that come into a hospital are skin diseases. So what this app will do is free up a lot of hospital resources for more important diseases, and skip over the simple things that we don't need hospitals for. So death count, over 200,000 deaths happen every year because of skin diseases, because most of the people ignore it. It's just a rash, it's just a simple spot on the skin, so it must not be deadly, right? So we just skip over it, and that causes a lot of deaths all around the world. So diagnosis, so all the skin diseases show some kind of visual signal that they exist in your body. So it is easily diagnosable using images. Ignorance. So as I already mentioned, there is a lot of ignorance going around associated with skin diseases, where people just think it's a minor issue and go along with their lives, and which will kill them eventually. Or not always kill them, but you get my point. So these are some more basic facts and informations which I think we should skip over because of the time constraint. So the working principle, right? So the working principle will be that we will extract the components from the images, key components from the images, using GAN or UNIT. Thank you. We were given some suggestions from our mentors, and I would like to thank Chris for that as well. And then we will classify it using a random forest classifier. This will give you the prediction on what the disease might be. Thank you to Vinod sir for that. And then we will use medical. We will use OCR to get the medicine information. So which will be explained by.
The second part is more about the application than the model. So what we were thinking is that we have we'll create an app in which what we can do is we'll take the user can input suppose the user gets the medicines from the doctor, right? So now what we need is that he will click the picture of the medicine, and we'll use a OCR for that. Which will segment. What am I saying? Just a second. We'll use an OCR for that, and what the OCR will do is it will segment the name of the medicine from that, and we'll also have a database for that. So the database will have all the data about the medicines and everything about them, like the doses and all, like how much dose that a person should take, and depending upon the age, if he is a younger one or the older one. Also the time of the dose, at the time which he should not take, what's the what are the side effects of the doses actually. And we were thinking of using a Google Vision API for that. And after that, once he gets to know, he will be provided all the information about that this should be the amount of dose that I have to take. This should be these are the side effects of that and all that. And we are also thinking of inputting a feature in which the person can include the basic prescription that the doctor has given to him. Like the doctor might have provided his own details about when he should take it and when he should not. So he can input that as well inside that. And the final thing that we were thinking to working on was that we can add a feature we'll provide him about the cost efficient medicine, the medicine which is more efficient for general users and are not that expensive. So this is the basic unit architecture. So it's an encoder and a decoder. It's an encoder-decoder kind of a system. What it does is that we create features from the first part and feed it to the second part. We have the skip connections inside the system. The skip connections are used to preserve the localized features actually. Okay, let's skip it. We don't have time.
So the time is up. I'll just give you the conclusion of it. So the conclusion is that it will have a mobile implementation, which will make it more efficient and mitigate discomfort. Since it is a mission critical system, we will have a high true positive rate and low false positive rate. Thank you for your patience.
With your tools you have, is it even feasible to model or not? What would be your guideline?
So what we were basing ourselves on is like the pre-existing systems that take your symptom and give you a disease information, right? So it's nothing, the project itself is nothing new actually. There's a lot of classifiers that check the skin diseases. So there's something called SunStar and there's something called Skin Vision, right? But what they are doing is like they are basing themselves on a very small scale. So one is targeting only skin cancer, another one is only targeting melanoma. And what we are trying to do is like create a more broader spectrum. So what we will not do is like give you a definitive answer always. So we will only give you a definitive answer when there is a huge difference between the probabilities of two different medicines. But if there is some negligible amount of difference between two possible diagnoses, what we will do is tell you to go to the hospital because you have this much probability of having this one and this much probability of having this disease. And we will leave the decision to them.
Yeah, this is a nice one, but I think you should not be writing that self-diagnosing and self-treatment. It should be a guiding tool which will guide you whether to rush to the hospital or you can go slowly, whether it is an emergent thing or not, right? So this is a good thing to decide by yourself before going to the doctor.
So what we were actually thinking initially was what we would do is have like an semi-trained medical professional use these applications in rural areas, right? So they would use this to use their own knowledge and the information provided by the device to make predictions and tell them whether the patient has like something severe that you need more advanced care for or not. But we thought like that would not be a very wide application or much applicable, so we changed it. But I guess
no, but you are not supposed to just give a generic medicine. The medicine that we use in skin are not just simple medicine.
Yes, we will keep that in mind if we further proceed with it. Thank you, sir.
Thank you.
Thank you.
No, my question was: are you trying to replace doctors?
So what we were saying earlier to the one ma'am is the same thing we will tell you. We are in no way trying to replace doctors. Doctors are medical professionals and they know much more than any machine algorithm could ever, try to predict in foreseeable future, I would say. Let's not claim that it will never happen, but foreseeable future will not happen. So what we are trying to say is like if you have something severe, you might go to the doctor. If you have something that is easily identifiable and like treatable, then you would not have to, and it would like free up a lot of resources in the hospitals. Yeah.
So, what did you guys choose? Skin disease. In what context?
Well, I could not. I don't know. It's not like something's happening to us right now, any of us right now. Well, as much as I have knowledge.
No, my question is: did you find, for example, skin disease is the most common disease in Nepal, and what was their motivation?
So the motivation was the overall idea of it. My motivation mainly was the embarrassment associated with it. Whenever you have skin diseases, you are very embarrassed. So they are mostly in like unseemly places. But the other issue was that the statistical issues, right? I saw a lot of statistics overall on the internet that says like skin diseases is the most ignored disease of all. So what we do is like we see some specific rash or some specific pattern in our screen, and we think like it's just a certain allergy and it will go away. So what we are trying to do is not raise some awareness to it that it might be dangerous and it might be fatal. So you should actually go to the hospital and get it checked if it is severe. Yeah.
So the gesture is something like. Nope. I'll do this again. Wrong. You guys are wrong again. So this actually means this is good and this is afternoon. So good afternoon. So it's real sign. Okay, so imagine this problem of not being understood every single day for your entire life, and every single moment you try to have a conversation with people. So what I'm addressing is of the problem of 70 million people who are deaf and 5.6 million people who are dumb. So our team has proposed on a solution to address this problem of automated sign language translation. So from regular conversations of eating food and like general talks to deeper conversations, we are gonna enable people who are deaf and mute to communicate with other people easily. So what exactly do we do? So our solution is translating videos, live videos to text and to natural languages. So the text can even further be broken down to natural language processing and giving out into voice. And we are gonna have a recommendation system that's gonna autocomplete the sentences the sign language people are trying to speak. So what exactly is the key benefits of this? The thing is, for a single translator, they cost around $50 to $80 per hour of their time. So not every single person who is a deaf or a mute can actually hire a translator. And we are gonna take the translator out of this equation so that we can enable these people through our solution. And the thing is, we can even these people can have faster communications. Like instead of just like typing text, like our systems is gonna enable them to speak faster, and so that people can understand in real time. So for next, we have for deeper stuff, we have Saramsha.
Hello everyone. Now I'm gonna give you a brief overview of the technicalities of our project. So basically we have two major aspects that govern our entire system, and the first would be to extract the features from the video clips that we have clicked of the people demonstrating the sign languages, and the next would be to use those words that has been classified as levels to actually generate natural language sentences to facilitate normal communication. Now, to go into more intricate details, we will be employing three-dimensional convolutional neural nets. So we have discussed 2D CNNs that can be used to, extract the features from photos and make an analysis on it. But videos are more complicated because they have features in both spatial as well as temporal axes. So we require a three-dimensional CNN to extract the video features. And for longer temporal dependencies, we'll be also using an LSTM layer on top of it, and the output from that system would be pipelined into the second part, that would be to leverage the language model that we have trained on in order to generate the natural language sentences. Now, okay, let us go briefly through what actually is 3D CNN. So 3D CNN has three-dimensional kernels, and it has strides on all those three axes. So what we are basically doing is we are dividing the video clips, videos into clips of 16 frames, and each of those would be used as input to the 3D CNN. And for those motions and gestures that last longer than it would be fed into the LSTM layer so that we could capture those temporal dependencies as well. And once that is done, the output from that would be used in order to predict the natural language sentences. So imagine a scenario when you are in a bank, a mute person is in a bank communicating with the other bank officials, and there is a televised screen that would be translating the sentences in real time, and our LSTM-based sentence auto-completion would allow the people to complete their sentences faster. It could also be implied or used in video conferences and help them perform basic communications like normal people. And we'll be using a data set. The data set that is available is the modern Chinese language data set. It is a comprehensive data set, but has been annotated with Chinese sentences. But we can use those videos in order to, make our own data set with the crowdsourcing in order to make it more genuine if you want to employ it in Nepali market. And another data set that has been commonly referenced in the literature is the German Sign Language dataset, which is also a comprehensive video word-based analysis dataset for this sign language. And we will be training this, the computer vision part, that is the 3D CNN, on this dataset, and we'll be also building a language model based on the basic daily conversation corpuses, and that will be the way we will be training our model, and we'll be actually bringing it to use.
So I'll be talking about the scopes and extension of our project. The one we saw earlier of our project was only the one-way communication process, but we have also seen use scope for the two-way communication process also. So it can also be extended by adding text-to-speech module for this project. And also, we can also bridge by adding voice-to-sign language using 3D modeling animation to provide end-to-end communication. So, yes.
Translation is again a universal problem. So I assume that this problem, a lot of teams like you from all around the world must be tackling this problem. So from your perspective, what competitive advantage, what unique value are you going to bring to this global problem?
Thank you, ma'am, for the question. So, based on our preliminary research, the most of the work has been done on finger spelling. So, basically, what they are actually trying to do is character-based sign language recognition, and that is only useful in those cases in which we do not have a proper sign language for that word itself. And there have been very less works done in actual word-to-word translation of sign languages. So, because video-based analysis is computationally more intensive and quite difficult. So I think that would be one of the new areas in which we'll be working on, where very few research has been done. And the next thing is we are also planning it as, like a real-time recommendation in which we can, lower down the bottleneck of communication. Like, for example, in video conferences, when you are a mute person is giving gestures and communicating, and if we can use the language model, LSTM trained with language model to, predict the most likely sequence of words that can follow to produce the sentences, we can, make the people communicate much faster. There can be a specialized gesture for the auto-completion as well. So in that way, we can make them communicate faster. So I think that would be one unique value proposition that we are adding.
So what do you think, which one will be more challenging? Sign to text or text to sign? Or speech to sign language or sign language to speech? You're tackling two problems, right?
Actually, our preliminary focus is converting sign language to text. In the last slide, we actually discussed that the implications does not just stop there, but instead we can actually build a reverse model to make it a comprehensive system to facilitate the end-to-end communication. I think the difficult part would be sign language to text, because video analysis is quite difficult, comprehensive computationally. So I think that would be the difficult part.
So your solution, you were saying, was to be deployed on a phone, right?
Not only phone. I think the main area where it could be applicable is like in applications like video conferences, where like you are communicating. People who do not have voice, they have a lot of bottleneck by communicating through text when all other people are having normal conversations. So I think in those cases, if we allow them to communicate in their natural way, that is through their gestures, but instead we are converting it into text and also providing the most possible likely sequences of words, so that we can speed up that process. So that I think is the main beachhead market if we are employing it. And the next case, it could be in the public offices like municipalities and banks and those public places where day-to-day conversations are very difficult to perform for those people. I think that those are the main places where you can employ. And if those prove our concepts and our belief, then I think employing it on phones for normal communication could be a solution.
So have you thought about, like, if you're using a 3D CNN, right, that's a pretty heavy computational step. So running something like that on a phone might be a bit difficult. Would you have any ideas about how you could circumvent that?
Yeah, so that is why we are actually focusing on those areas that are most dependent on cloud, like video conferencing and just as I explained, in those public places. And the phones can come in secondary if, like if technological advancement and any other workaround can help us go through. So I think that's it. Thank you.
Okay, we have the.
Hello everybody. Good afternoon to all of you first. As it says in the projector, our topic is vehicle detection to predict traffic flows. And so, show of hands who have never been in this situation. And no one, I guess it. Yeah. So in Nepal, everywhere there is traffic jams, and you cannot go past from one place to another without getting past what is this? A checkpoint without this traffic, and there is a single traffic person to manage all of this, and that is not really practical. No. So we are stuck there for hours even to get from one 2 kilometers. So we proposed a solution to detect those vehicle flow in times at time frame throughout the day, and record the normal data flow for every time frame. So we could analyze this with newer data, so we could detect traffic jams and hopefully avoid such situations. And our key applications is to automate such currently time-based traffic management, such as those traffic lights. They run on certain time limits, so that so it does not address the problem that some intersections have more traffic flow than others. So we are hoping to collect data to manage such problems. So our methodology is to use current CCTV footage and train a deep neural network to classify vehicles from other objects, and predict the flows of such traffic. So basically, we are going to detect and locate vehicles at any current time frame, and predict that, calculate the traffic flow at any current time, and collect the data to further train our model, so it could give more accurate data to predict the traffic flows for future, and plan the traffic route throughout the other throughout other intersections, and hopefully prevent traffic congestion and other stuff. So to explain our methodology, I would like to call Elena Devkoda.
So
So in order to fulfill our objective, what we did was we looked at how to use OpenCV-DNN module with pre-trained YOLO model to object for the purpose of object detection. So YOLO is one of the fastest detection algorithm, naturally sacrificing some accuracy. Because of its swift detection mechanism, it can detect objects in real time, uptime 30 frames per second. It uses Microsoft Coco dataset, which can detect about 80 classes, including various types of vehicles and other objects. So the architecture of YOLO is shown in the figure, where the YOLO network has 24 convolutional layers followed by 2 fully connected layers. And after each layer, there is alternating 1 by 1 convolutional layers to reduce the feature space from preceding layers and other complex things. Okay. Here, the graph of performance of YOLO v3 with Coco datasets is compared with other model. From the graph, we can clearly see that the speed of detection by YOLO v3 is least with appreciable accuracy. So how does YOLO work? What YOLO does is it sees entire image rather than sliding window, which is more common in CNN. The network firstly divides the image into different regions and predicts bounding boxes for each region. When it detects bounding boxes, what it does is it also predicts the probability of bounding boxes in each region. So from what I understand is that, from a paper, is that it divides the given image into different grids, and for in each grid, it determines B bounding objects. We can also set it ourselves. So in every grid, after finding the bounding boxes with different probabilities, what we have to do, what the YOLO does next is that it drops the boxes with least probabilities, and for the remaining boxes, it determines the classes with highest probabilities. And here in the figure, we can see that the bounding boxes with highest probabilities is given in fatter, is shown in fatter boxes. So what we did was we captured image from a place nearby and fed it into our prototype, and we have been able to count vehicles that are coming. How does our system help society? So what our system can do is it can help to reduce traffic congestion, which is going to reduce waste of productive hours, and we can also predict catastrophic events on the road and help reduce health issue of traffic police by replacement of manual job by autonomous system. The challenges which may arise in our work is that it is quite easy to detect objects in a particular frame, but it is very difficult to identify the same vehicle in multiple frames. And also, even if YOLO can predict images predict or detect objects very fast, it has not been able to meet the certain level of accuracy. It also struggles to precisely localize some objects, especially the small ones. So in the future, what we expect to do is track vehicle from number plate as well, and we can also use the system to suggest alternative routes in case of high vehicle density. So we're also having a thought that if our system fails to detect to fulfill our objectives, we can use the model to identify pizza in the images.
Data, right? And I just looked at the parameters, there's vehicles and dogs and everything. But if you use this model in the street of Kathmandu, you'll find the cow and cattle, right? In that case, what is your model going to do?
We've actually restricted the classes that the model classifies to detect only vehicles like car, buses, and like bikes and bicycles.
I wasn't sure. Did you use the footage you took in Kathmandu to implement the algorithm?
We tested on that sample like.
Oh, yeah. So you actually implemented the algorithm on a...
Yeah.
We actually use pre-trained model.
Basically, you have a pretend model from the Microsoft data, and you use the video sequence of a Kathmandu road. Yes. Yeah. That is quite pretty good job, guys. Yeah, really.
Thank you.
You know, I was thinking about something like this for ambulances, because I have seen ambulances being stopped in traffic. So if you can just start with ambulances and letting the traffic in the center know that which direction the ambulance is coming and where it is stuck, then maybe he can stop that on the other side and open that side so that the ambulance can get an easy path. Maybe that can be the first use of it.
Yes.
Thank
Obviously,
you.
like we would like collect data and never like stop those congestion from ever happening. Like there will be like a free flowing.
That's even a better one, yeah. Okay.
Thank you.
We are a team of 10 enthusiastic students and peoples who do care about impactful ideas and innovation. We are Team 9 and we're here to present our idea, Plantify. Pronounced as Plantify and written as Plant If AI. So it is an AI-based plant recommendation system. So we would like to thank our mentor, Azad Satkuli sir, and special thanks to Chris Sankaran and Bishesh Khanal. So I cannot ask you if you have seen plants or not. So what I can do is I can tell you a story about a place in Morang, and the place name is Kerabari, but there are no keras. The place there is very good at lemon. Recent studies shows that. But the people there, they grow rice in there. So recently we found out that one of the agro-investor went there and did lemon farming, and he was expecting something, and he was quite, he felt quite good that that increased the productivity of lemon, and that is irony.
Being the citizen of the agricultural country, what can be more devastating than being the major problem, the increasing of the desolate land? That is, our lands are going barren, they are not being cultivated now. And then another is, we are in our villages, every farmers are planting just the traditional crops. They know what their fathers and grandfathers had taught to plant in their fields, but they have no idea what are the commercial goods, what goods give their more profits. And another is, we have seen the urbanization all over the cities these days, and people starve for the fresh food, for fresh vegetables. And if they can plant the vegetables in their rooftops, then it can be a very good opportunity. And if they begin to plant the vegetables in rooftop, they have got no idea from where to get the soil. Then what sort of soil is it? Which vegetable is suitable for such sort of soil? So for that, for these sort of problems, we have come with the solution, that is Plant If AI, intelligent farming system. On our project description, we are taking the soil sample images from the different places, and we are taking these images for training manually at the beginning, and also the internet data. And we are not only depending upon the soil for the information, but we are also taking the environment, weather condition, that is the temperature and humidity, which can be obtained from the weather stations that are present all over the country. And these data are trained in the model, and our model will predict what sort of crops will be suitable for the particular location. Then the major benefits of our system will be, it will recommend the highly beneficial, productive crops for the farmers rather than the traditional crops. And it also assists the local farming expertise for helping the farmers to predict what sort of crops will be planted in their fields. These are the weather stations all over the country. And we are taking the data manually. At the beginning of our project, we are taking manually the data from the fields. I'd like to call Vidurbo for the deep neural stops.
So thank you, Sitish, for your presentation. Now I would like to continue with what kind of architecture we are planning to use. In our case, the major problem is the limitation of data, because in today's context, there are not much organization working in the collection of data like soil data and correlating it with certain crops that would be favorable in that environment. So, we have divided our architecture into two parts. First one is the teacher model. So this model will basically learn the latent representation of the on-level soil data. We can easily collect on-level soil data. So we think that it wouldn't be a problem. So after learning the latent space representation, we could use this in our actual student model. So the transfer weights from the previous autoencoder could be used in this model. And the problem with this model is that we have inputs from different modalities, like we have soil image, and the next is we also have weather stations data like altitude, temperature, humidity, and rainfall. So our job is to combine these data and train a model so that we would be able to categorize, we would be able to recommend what kind of crops is favorable in that environment. So after that, I would like to talk more about how we are going to approach this project. First, we'll start with the feasibility research, and then we'll continue with the data collection. In our case, data is a crucial part. We need to collect data from different parts of the country and correlate it with the types of crop. So that will be our tedious part. Next is we will develop the model and try it, and there comes the testing and maintenance. So the challenges with this project is obviously the data. We don't have enough soil data, so it would be a tedious job to collect the soil data. And also, we can collaborate with government organizations, but it can be a hassle, you know. So this is our conclusion, and this is our AI recommendation system, and it could be used for portable farming, like if you have soil from different parts of the location, so we can simply use our system and we can plant the recommended crops. So do you have any questions? Thank you.
Which means farmers have been relying on agriculture for hundreds of years with the traditional knowledge of how to farm. So why should a farmer listen to your AI machine and not trust his knowledge? And then my second question is, I forgot. Okay.
So the knowledge that the farmers use is from a local perspective. I mean, they usually have the knowledge within a confined area. So there can be possibilities like, let me give you one example. The apples in the that Mustang is famous for apples, but initially apples were not from the Mustang. It was an idea of one person who planted apples in Mustang. So there can be different possible plants that have that we could grow in Nepal. So why just rely on traditional crops? So we can explore different other crops that yields good results. So
can I add something to that? So, I mean, why would a farmer would be convinced for that? So the thing is, according to the statistics, it says that around 65% of population is involved directly or indirectly in farming. But having said that, we have around 6.9, around 7% of population which are not cultivated. So the problem is we do farming at the seasonal farming that we do has certain disadvantages. I mean, the kind of fertilizers that we use for one kind of crop is not suitable for the other. So we keep those kind of crop, for particular season. So if we could recommend particular kind of crop for this kind of soil type, I think we could overcome that. So that was the small margin that we were targeting. Thank you.
So I had a question, if you could expand a little bit on the visual part of it. So from what I understand about soil, it's mainly about chemistry. So what makes you think that like classifying soil by imagery is going to tell you something about how good the soil is for something?
We researched on it, and we found that the color of the soil is affected by the organic manures present in it, and the oxidation state of the iron and magnesium present in it, and which helps to determine what is the composition of the oxidation state and the organic manures in it.
Let me add one perspective to that also. Like usually textures in the soil, they help us identify types of soil. So based on that, based on the physical characteristics, we can actually identify the types of soil, and different types of soil are good for different plants. So
when you are saying soils, what do you mean by soil here? Like you are taking a picture of a soil, or like collecting a sample and taking a picture?
Yeah.
Do you think that will be better, or taking a satellite images of those places and analyzing will be better for the soil quality assessment?
So we also thought about that. So right now we are just this is just our idea. So we will have to experiment with that. So
Satellite images are not good enough for capturing the exact quality of the soil. And then another thing is from the Google Earth or something, we need a very live picture of our soil. That means up-to-date picture. And then from the satellite, we cannot get the up-to-date picture of our country. So that's the problem.
Yeah.
I think in Nepal there are like a number of really good ICT-based agriculture solutions, and which have also won some international awards. Are you aware if any of them have used AI-based solution? And if they have not, why do you think so?
Yeah, so that is the problem. That is I would say there's a lot of problem in a country, and if we see that as an opportunity, I would say there's a lot of opportunity. So there has been number of attempts for that. So I have gone through a few of them. So like I've been through Agrovate, which is already in the market. They are doing classifying the diseases by scanning the leaf, and other than that, the next thing is if you are having some kind of problem, there's a bunch of contacts that you can try out. So the approach that we are trying is a little bit different than that, I would say. We are actually trying to like reach to the individual. Suppose if you are taking that picture, a farmer can take that picture. An Android phone is available to each and every house. This is common nowadays. So a farmer can take a picture and upload to our database. The first thing is crowdsourcing of data will be better with that. And second thing is not only disease classification. We are targeting a bunch of crops, because if you study a soil, you are targeting a bunch of crops. But if you study a particular crop, then it's a limited window. So that is what we are trying, I think. Thank you.
Shashank are here to present our Team 10 idea, plant disease identification. We were mentored by Pascal, and thank you for your great mentorship. So our idea, it is plant disease identification. What we are trying to do is to detect diseases in plants, visual diseases which can be seen in leaves and stems in such diseases. Those diseases are mainly caused by environmental conditions, bacteria, fungi, and such. The main motivation for our project was the food demand in the world is increasing. Population is increasing, and with it, the demand for food increases. But a big problem in the farming industry is that there is a loss in yield almost 20 to 40%. That is direct the direct loss in the yield, including in the world, including all the developed countries. The situation in our country is much worse than 20 to 40%. The main advantage of doing plant disease identification would be the farmer would be able to know about those diseases early on and could act early. Second thing, you would not have to manually go through the farm, and thus his time would be saved. Manpower and time saving would also be there. Also, there would be significant increase in the crop yield or his product, as he could act early on the problem and work on the solution. This would also help in national economy in agrarian country like Nepal. Our country is mainly dependent on agriculture. Sorry. So what we are planning, or how we are planning to do is, we are planning to make a system that automatically detects diseases in plants by looking at the images, mainly the leaves, leaf images. We would look at those images and see and detect any diseases in those plants. Once we detect the disease, we would suggest the possible remedies to those diseases to the farmer. To explain more on how we would do, I would like to call my friend Sasank.
You guys do remember about Siamese network, right? We had just studied about it yesterday. So yeah, what we are trying to do is use the Siamese network. Yesterday we talked about Siamese network for face recognition, and we kind of thought about it, and we saw that, well, even the leaf data is going to be like quite similar, right? So what Siamese network is basically doing is it's checking the dissimilarity between highly similar data. So we just thought that why can't we use Siamese network for leaf classification? I mean, plant disease classification. And when we looked into it a bit more, we found out that there was actually already a paper which has used AlexNet and LeNet architecture to classify the plant diseases. So we thought of actually trying to improve the existing paper by applying a wrapper of Siamese network over it. So the data that we will be using is a plant village data set, which is already being used in the existing paper. So it will kind of be like a validation for like, you know, to see how well our network does. And yeah, so this is the paper that has already been published. So they have classified 38 different classes of plant diseases, and like those are the results that they have. And the Siamese network that we would be using, we actually have two different architecture where the only difference is the loss. Yesterday we saw that we could have probably used triplet loss, right? So for a triplet loss, we can give a positive image, negative image, and then our anchor image to find out the triplet loss, right? So we thought that it might be a little tedious, or it might actually be an experimental way of checking like another loss, contrastive loss, where the contrastive loss only checks like how well it, wait, I'll just, yeah, so the contrastive loss will actually check how well it does for the same class, and it will compare with with a certain threshold. If it has been misclassified, we will check how how the probability of it being in in the same class that we're looking for. Whereas the triplet loss formula, it is actually basically the same thing that we saw yesterday, right? So, yeah. And what we aim to do with our network is like after the classification, like let's say we have this leaf and this leaf, they actually look pretty similar, but we can see that these are actually holes and these are like some moss, kind of white moss. So they actually look similar, but they are pretty different, and we aim to classify which disease they fall under. And after the classification of the disease, we aim to give the solution of what might be done, like based on the classification of the disease, right? So, and I would like to pass on the mic to Deep again.
So what he explained was that we would use we use already available data to train our model, but to test, we need to have real-time data collection. For that, we would first go to farmers, ask their permission, and if they need our help, then we would use drones to collect the data. So one thing we thought of was, could we make a profit out of it? Could we earn something? For that, we looked for similar oaks. Were there some similar oaks? We found two really successful startups, one Canadian and one US. So I think we could make a profit out of it in a country like Nepal. Where also, we thought about what we could improve. Currently, we are detecting the plant diseases and then recommending what could be done to solve the disease. One thing we could do was to also detect the crop quality, what the quality of crop a farmer is growing, and we could comment on that. Another thing we could do to improve our system was to suggest ways to improve the yield the farmer makes from his field. Thank you.
So I have a question. So in the context of Nepal, which plant disease will you go for and why?
So in the context of Nepal, we can probably see that we have blight, like we can see blight a lot, like lots of cornfields have been demolished because of blight. So blight is one of the major diseases that we have to look into. And some other diseases might be like, in the Himalayan regions, we can see rust, which cannot be like seen probably in the like lower regions, but we can do like region-specific diseases, right?
So you are developing this plant disease detection, and I think one earlier group were developing the skin disease detection. So then you said that, oh, this is not going to make profit, but that skin thing is going to make profit, right? So if you want to go into that domain, so how competitive can you be? What would be your competitive advantage and what would be your competitive disadvantage?
Actually, skin disease detection would probably fall under different domain, but we can probably use the same algorithm for skin detection as well. So we would probably be giving them a tough competition.
I was curious about, like on a technical level, you were thinking about extending things using some sort of meta learning or like one-shot classification idea.
Yeah.
I'm actually curious about, it seems like in real world, outside of Kaggle, you're probably going to have a lot of sort of supplemental like metadata information that might be useful, right? You might know where the image was collected. You might know kind of the different kind of meteorological characteristics, right? So it seems like that sort of information could actually help classification as well, right? So do you have any idea about if there's any data that you would want to collect besides just what the Kaggle competition people have already collected and how you might be able to incorporate that?
Well, for the initial training stages, we can probably use the Kaggle dataset itself just to see how well our algorithm might work. And then if we plan on expanding, we would definitely have to look into like all the metadata, like how we linking to the same question that was asked earlier. If we want to like make a region-specific algorithm, then we would definitely have to look into the metadata. Yeah, we would have to see whether the plants, like the data came from the Himalayan region or the data came from the Tarai region. And if we have a region-specific data, then we can probably train our data accordingly to like get higher accuracy for that particular region. So, yeah.
Okay, no more questions. Thank you, team.
First of all, I want to thank NAAMII for organizing the winter school for all of us. And especially, I want to thank our mentor, Dr. Binod Bhattrai sir. This is Ms. Rizana representing the group 11. And our main idea is max pooling in computer vision. What's the max pooling in computer vision means that it's like, basically, it's like max pooling in computer vision. Why shouldn't we use the k-max pooling instead of max pooling in the last layer of convolution neural network? And here we're gonna present is that in the max pooling, the basic and its application, and in K-max pooling, the basic and the application in the natural language processing, and why not in the computer vision. And about that proposal, we are going to present why to use K-max pooling and how to use K-max pooling in computer vision and its pros and cons.
So this is how we generally do a max pooling in our traditional convolutional neural network. So we take a filter with a size, and we take the maximum value and decrease the dimension, right? And the main purpose of max pooling is to reduce the dimensionality. So what we are doing is multiplying multiple kernels with the image. So there will be a lot of two-dimensional matrices, and we want to decrease the dimensionality. That's why you do max pooling. And there are different types of max pooling, like max pooling itself. There are different types of pooling, sorry. So max pooling is taking the most greatest one, and average and aberrative max pooling, meaning that despite of the size of the input image, we adapt the kernel size so that the output will always be the same. So about K-max pooling.
Now, the main idea for our main motivation for this idea comes from the very fact that K-max pooling is already being used in NLP, but not in CNNs. And the reason, and it makes pretty much sense to use that in NLP, because suppose you have a sequence of words, and it may happen that the most important words are actually next to each other. So if you apply a one max pool layer in that sequence of words, you may end up losing the second most important word of your whole sentence. And so it makes sense to use K-max pooling in NLP. But why is it not used in CNN? Consider this image on the left, right? So, and this is your receptor field, the orange area. And suppose you're applying K-max pooling in this part of the region. So the pixel that you will get from this will be blue. The next pixel you will get will be again blue, and so on. So it will be redundant to use K-max pooling in a high-dimensional image such as this one. But now look on the image on your right? So here, the receptor field is really large, and it is representing more than one important feature of your image. So if you apply one max pool over this region, you will be losing some important information. And this is what happens when we go into deeper layers of our neural network. The receptor fields keep on increasing, and so we need to apply K-max pooling in the deeper layers.
Okay, I'll just revisit this thing. So initially, like this is for like the initial layers of the neural network, and this is for the final layers of the neural network. We can see in this photo how the receptive field increases as we go up, like we go above in the architecture in the layers. So we can see if the receptive field increases, so we might be losing some of the information if you're just taking one max pooling. So yeah, so how to do K-max pooling in CV? So initially, what we propose is start with just one max pooling for the initial layers, and then keep on increasing the K in a linear fashion or in some different fashion for the final layers. So like initially, suppose we have an image of size 32 cross 32, and we apply a conv of 5 cross 5 to get an image of size 28 cross 28, and then we apply just two max pooling, so we'll get some 14 cross 14 cross 2. 2 just because like this is the maximum value and this is the second max value. And then we propose like max pooling is basically used for translation invariance and reducing the dimensionality. And so if you're not reducing the dimensionality much, it's of no use, right? So we say, okay, add a 1 cross 1 conv layer instead of just ahead of it, so that it will be able to choose between like whether to take the maximum value or whether to take the second max, or the weight is between them. So this is the classical max pooling architecture for simple CNNs. Like you apply a CNN on a image, get features, and then you max pool. In here, the proposed K-max pool is simply like you get the features, then you apply the K-max pool. So for each of the, like instead of the one-to-one correspondence for each features, you get like it's a 2 max pool example. And then we apply a 1 cross 1 conv, so it can learn to take which one it wants, like the maximum or the second max. And then, yeah, so it generalizes to the existing pooling. Like if we have a 1 cross 1 conv layer, so it can just say like, hey, for max pooling, it will be just 1 0 0, so it will just be taking the maximum value. And if K average pooling, so it will just be taking the average of the 3 most max values. Yeah. So why a 1x1 conf? Because the whole point of max pooling is dimensionality reduction and providing translation invariance. So of course there's a trade-off between the dimensionality reduction and the number of parameters. So we want to experiment on it. Yeah, this is a small code snippet in PyTorch I wrote. Yeah, so pros and cons. So of course, cons are like we are getting extra parameters and it might overfit because we are giving more features for it to learn. But the pros are like in the case of this example, what color is the thing with the same size as the blue cylinder? It requires that like multi-level reasoning, and this kind of like in our hypothesis is that in these kind of setting, k-max pooling would be more efficient than simple max pooling. Yeah, so in a nutshell, we apply simple max pool on initial layers, and then we start increasing the k for k max pool to subsequent layers, and where capital K is the hyperparameter, and after which we use a simple 1x1 conf. Yeah, that's it.
Beginning is that for NLP, it's these kind of nearby but always important words which are being chosen by the k-max pooling. So I'm curious whether, is there some sort of statistic or information you can collect after you train something to say that the k-max that I'm choosing, like how would you know, like what are your hypotheses about where it's pulling information, right? So I'm guessing you're expecting it to be pulling the k-max from nearby places or from like diverse places in this image? Like, yeah, what are your hypotheses? How would you check?
So initially in the layers for like the first layer, it's just the receptive field is very small, and that's why even if we take the k-max, it would be just taking from the nearby places, and then images like locally coherent, so we won't be able to get like much diverse features. But as we get in the last layers, like in the farther away layers, the receptor field has increased, right? So the same conf feature, the same conf feature would be basically representing a much larger receptive field. So taking k-max might be able to take take the maximum features from diverse places in the image.
How do you choose k?
Yeah, that's a hyperparameter.
So you
have to use
basically
cross validation.